Concludes our last lesson of the term of the semester, and what we're going to be learning about today is adding, subtracting, multiplying, and dividing. Rational expressions. There's no vocab. This is just about algebra. So heavy-duty algebra in this lesson. The first thing, whenever you're adding or subtracting anything to do with algebraic expressions, and they are rational, which means they're fractions, the biggest and most important thing that you need to know on this slide is you need to have common denominators. That is the most important thing when you're adding or subtracting fractions, or in other words, rational expressions. In this first example, number 1, what you'll notice is that the denominators are both the same. They're both 12. So that's great. We don't have to really do a ton of work there. You just leave the denominator if they're the same, and you just put the two top things together. Since those are not like terms, you just write them down, and you're done. In problem number 2, what you'll notice is that the denominators are not the same. And the only thing that you can do in order to get them the same is to multiply by something. So down below, I notice that there's a 3, and on the right, I notice that there's a 5. And I ask myself, what could I turn both of those numbers into through multiplication that's the same? And the answer is 15. So I multiply the left fraction by 5, top and bottom. And I multiply the right fraction by 3, top and bottom. Now when I do this, the left fraction turns out to be 15x minus 10 on the top. The right fraction turns out to be 3 times x, which is positive 3x, and 3 times 3, which is positive 9. What's the common denominator? 15. So on the bottom, I put the number 15. And then what I notice is that on the top, I have some like terms. The 15x and the positive 3x are like terms. The negative 10 and the 9 are like terms. So that when I combine them to make my final answer, on the top I'll have 15x plus 3x, which is 18x. I'll have negative 10 and positive 9, which is negative 1. And on the bottom I have my common denominator of 15. In number 3, the denominators are 2x and 4x. Remember, you can only multiply, and you want to turn them both into the same thing. I can use the first fraction, and if I multiplied the top and the bottom by 2, I would turn the bottom into a 4x. And now I would have 4x for the left fraction and 4x for the right fraction. Or in other words, my common denominator would be 4x. On the top, the 2 times the x is 2x. The 2 times the negative 2 is negative 4. Bless you. I still have the 2x, that's positive, and the negative 3 from the right-hand fraction. And so what's going on now is once I've got my common denominator, I don't write it down twice. I write it down once on the bottom, because it's the same for both fractions. And the top I adjusted in purple because I was getting that common denominator. Then I look for those like terms. So I see the x's that can be put together. I see the numbers that can be put together. And then I write my final fraction after I do that as 2x plus 2x, which is 4x, negative 4 and negative 3, which is negative 7, and the common denominator of 4x on the bottom. You do not cancel out the 4x's. That's not allowed. You're writing it as one fraction. In order to cancel top to bottom, you would have to have common factors that you could pull out and then reduce. Number 4, you'll notice that there are 2 parentheses in each fraction. In the first fraction, what I see that's missing is the parentheses of the x plus 2. Do you guys see that from the second fraction? It's not on the bottom of the first fraction. So what I'm going to do is I'm going to multiply the first fraction by x plus 2, top and bottom. On the right fraction, the thing that's missing there is the x plus 1 fraction from the left fraction. So I'm going to multiply the second fraction by x plus 1, top and bottom. Now as I look at these, I notice that the pink stuff has created a fraction that has x plus 2, x plus 1, and x minus 2. The purple one has created the same bottom. Different order, but the same bottom. The cool thing is, it doesn't matter which order it's in because multiplication is commutative, which means you can organize it any way you want to, like 3 times 2 times 5, 2 times 5 times 3. Doesn't matter, gives you the same number, 30. So the same is true with algebraic expressions that are factors. You can do the same thing. So my common denominator, if I rewrite it now, I would get on the bottom x plus 2, x plus 1, and x minus 2. And it wouldn't matter to me on a test which way you write it. So you can organize the bottom. As long as those 3 parentheses are there, you're good to go. Now on the top, however, you have to be careful, because what I see is x plus 2 times x minus 3. That's a foiling situation. You're going to use the binomial expansion and FOIL that out. So when I rewrite the pink stuff, x times x is x squared, and positive 2 times negative 3 is negative 6, and then I have positive 2x from the inners, negative 3x from the outers, which gives me a total of negative 1x overall. And that's the pink expansion. I also have to do the purple expansion. So in the purple expansion, 2x times x is 2x squared. Positive 1 times positive 1 is positive 1. The inners produce 1x. The outers produce 2x. 1x and 2x makes a total of 3x. And this expansion is the foiling again of the purple stuff and the pink stuff. When you write your final answer, you have to look for those common factors on the top. So this time there are 3 different sets. We have the x squareds that go together, we have the x's that go together, and we have the numbers, or in other words, the constants that go together. So as I write my final answer, I have to take into consideration those things. I leave the denominator the way that I had it before. So when I write my final answer, on the bottom, I'm going to leave parentheses x plus 2, parentheses x plus 1, and parentheses x minus 2. This was the common denominator. Leave it. X squared and 2x squared makes a total of 3x squared. Negative 1x and positive 3x makes a total of 2x. And negative 6 and positive 1 makes a total of negative 5. So the final step here, just in case, is you need to check to see if this numerator can factor and then cancel anything top to bottom. So like if there was a common factor, or if you could factor it into 2 parentheses and then reduce, you need to check for that. So I'm going to check just to make sure. On the top, what I could do is I could write it as 3x in a parentheses and the second one x. And then to get the 5, I need a 5 and a 1. So I think that 5 would go in the first and 1 would go in the second. If I put a plus with the 5 and a minus with the 1, that's the factorization of the numerator, because 3x times x is 3x squared, 5 times negative 1 is negative 5, positive 5x from the inners, and negative 3x from the outers would produce the 2x. So that's the factorization. If I write the denominator down again, what I notice is nothing in this case reduces top to bottom. But there was a possibility that that could have happened. For example, if that x minus 1 on the top was the same as the x plus 1 on the bottom, if they were both like pluses or both minuses, then I would reduce it and simplify it. So you should check. Number 5 is a little bit easier than that one, I think. You notice that there's an x plus 3 on the left fraction, x minus 3 on the right in the denominator. You can't add or subtract when you're getting common denominators. You have to multiply. So in order to make that work for us, we're going to have to multiply the left fraction by x minus 3, top and bottom. And we're going to have to multiply the right fraction by x plus 3, top and bottom. Now the good news about that is that our common denominator then is the x minus 3 and the x plus 3 together, because now both fractions have both of those things. I don't care which order you write them in. In the top, from the red, I'll have 5 times x, which is 5x, 5 times minus 3, which is minus 15. And from the purple, I will have 2 times x, which is 2x, and 2 times 3, which is 6. So now, as we've done in the past, you combine the like terms. I have the x's that go together. I have the numbers or the constants that go together. And when I write down my final answer, I'm going to get on the top 5x and 2x, which is 7x, and negative 15 and 6, which is negative 9. And on the bottom, I would have those two parentheses, x plus 3 and x minus 3. So in these last two problems where you see subtraction, really the only thing that you have to do to make sure you're going to do well is wherever you see a minus sign, change it. So I see a minus sign between the two fractions. I'm going to change it to